Okay, so welcome to the angles unit. We got our vocab sheet last night, and a lot of these words were hopefully familiar to you. You've heard supplementary, complementary, acute, obtuse, right? You've heard most of those. You've heard bisector in Unit 1, and that was on your test, the word bisector, right? Bisect means cut in half, divide into two congruent parts. So let's go over the ones on the warm-up today. Supplementary angles. Supplementary angles, a good picture was letter E. Supplementary angles are two angles that have a sum of 180. Awesome. An angle by itself cannot be supplementary. Supplementary has to be a pair of angles. Okay, number 2, an acute angle. We picked F. And what makes F an acute angle? Why does it get that classification? Good. It is less than 90 degrees. So it's any number between what and what? Any angle degree between 0 and 90. Very good. No, Fong, a straight line cannot be supplementary because supplementary is a pair of angles. And it says that on your vocab sheet. Not 1 and 89. An acute angle would be an angle greater than 0 and less than 90. Because there's still some numbers between 89 and 90. 89.2, 89.7. So it's greater than 0 and less than 90. Okay, vertical angles. This one might be new to you. It might be new, but it is the word we're going to use most often, and we're going to use it all year long, not just in the angles unit. So we're going to talk a lot more about these later, but angle 1 and angle 2 are vertical angles. Angle bisector, I talked about that a second ago. Bisect means divide into two congruent parts. So A is a picture of an angle bisector, and I'll talk more about that notation in a minute. Complementary. Y is B, an example of complementary angles. Because their sum is, yes, 90 degrees. Their sum is 90 degrees. 50 plus 40 equals 90. And then finally, the last one, process of elimination. This one is an obtuse angle because it is greater than 90, but it's less than what? An obtuse angle. We want to be greater than 90, but less than, good, less than 180. So we don't really speak of angles greater than 180. We don't speak of those in here. The angle that shall not be named. No, but if you go greater than 180, it's actually called a reflex angle, and we don't really spend time measuring reflex angles. Instead, we measure the other angle, and we can just subtract it from 360 if that makes sense to you. So let's go over our vocabulary. If you didn't get a chance to do your homework last night, which was to fill in these words with the Quizlet, that's okay. But there is a Quizlet, which is just online flashcards that I want you to be practicing with over the weekend, hopefully. You like my Harry Potter reference? Make sure you have these words on your notes, and while you're filling them in, I will embellish them and talk about them. Let's start with an angle. What is an angle made up of? What are its parts? What makes an angle? An angle is made up of something we learned about in the first unit. Very good. You can't have an angle without rays. So an angle is made up of two rays that have a common end point. Very good. So an angle really isn't an entity by itself. It's a compilation of two rays. Two rays that have a common end point. We're going to talk about how to name an angle in just a minute. This is called the interior of the angle. The interior is anything inside these two rays. And then anything out here would be the exterior of the angle. Complementary. Those are angles whose sum is 90. Sum is 180. Let me give you a hint of how to memorize that because people get them confused a lot. Complementary and supplementary, they mix up which ones add up to 180 and which ones add up to 90. So you've got your C for complementary. You've got your S for supplementary. You can turn the C into 90. Ooh, ah. And you can turn the S into 180. Ooh, ah. So I hope you never get them mixed up again. Write down the letter that they start with and hopefully turn it into a 90 and 180. Okay? All right. So then we've got our 4 classifications. If I say classify this angle, it means put it into a category. So if I said classify this angle, you would say acute. Ooh, that's good, Nathaniel. That's good. I'll talk about that, okay? Yep, you would classify it means put it into one of these categories. So we've got obtuse, and I think of obtuse as big, greater than 90, but less than 180. You've got your right angle, which is just so perfect. That perfect 90-degree angles, they're always right. Then you've got your straight angle. A straight angle is created by taking a ray and rotating that ray how many degrees? How many degrees do you rotate that ray? 180 degrees. When you rotate it 180, ooh, what vocab word are these 2 rays called? From first unit. We didn't talk about it very much, but we talked about it. What are those rays called? Starts with an O. Yes, they're called opposite rays. Very good. So those opposite rays make a straight angle. And then you've got your cute little angle, acute. Acute means tiny. It means small. It means less than 90 degrees, but greater than 0. So we're not going to discuss negative angles in here. I'll save that for your pre-cal teacher. We're going to be discussing mainly angles between 0 and 180. Every now and then we'll go past 180. A linear pair. In addition to vertical angles, linear pair and vertical angles are going to be the biggest players throughout the whole year. So it's really important we know what they are. A linear pair literally has, what it is in the name. What do you think of when you hear pair? You think of 5, right? 2. Yes. Pair means 2. And then in the word linear is the word line. So linear pair is 2 angles that together form a line. Not lime. So a linear pair, there's my line. It's any 2 angles that together form a line. So someone said, is linear pair the same as supplementary? And that was a great connection to make on day 1 of the unit. Now, linear pair, because they make a line, are linear pair angles always going to be supplementary? Yes. So a linear pair will always be supplementary. I'm going to put an A for always. But it doesn't work the same way. It doesn't work the opposite way. Supplementary angles will only sometimes be a linear pair. Because remember in the warm-up, I had 30, and then I had 150. And if those angles are rotated and they're not forming a straight line, if they're not connected and they're separate in your diagram, they're only supplementary. They're not a linear pair because they're missing this word. They're not arranged in a line. They're not arranged in a line. So, linear pair is always supplementary. Supplementary could be a linear pair. Could or could not. Okay, adjacent means next to. I say adjacent, you say next to. Adjacent. Next to. Adjacent. Next to. Okay. Well, next to, like T-O. Okay. So, 2 angles that are adjacent. Here we go. Like angle 1 and angle 2. Are 2 angles that share a vertex. That's what this is called. They share a vertex, and they also share a ray. That's really important. See how angle 1 and angle 2 have this ray in common? They're both using that ray to make their angle. Now, if I had a picture like this, angle 1 and angle 2 are kind of close to each other, but they're not adjacent. They're not next to each other. They're not sharing anything except for the vertex. So adjacent means next to and sharing array. Okay, vertical angles. To make vertical angles, you really need the letter X. Can't make vertical angles without the letter X. So when you have the letter X, you create two pairs of vertical angles. So if adjacent means next to, vertical angles kind of means opposite. So what angle is vertical angles with angle 1? Angle 2. Vertical angles. What angle is vertical angles with angle 3? Angle 4. Vertical angles. I'm putting arcs to show which ones go with each other. Double arc and a single arc. Okay? You know what congruent means? Congruent just means they have the same measure. The same measure. The last one I want to talk about is an angle bisector. Bisect means cut in half. So, in our last unit, we were cutting segments in half. If I drew, let's say I drew the perpendicular bisector, what symbols did we add to it? We added that right angle, and then we added tick marks. So tick marks were the symbol for me to communicate to you that, yep, that really did cut that segment in half. This point really is a midpoint. Well, how am I going to do that with angles? With angles, how I'm going to do that is I'm going to draw my angle bisector, and to tell you that that really is cutting the angle in half, I'm going to put arcs, just like that. Now, if I need to show you that two more angles were cut in half, like, oh, now I'm going to bisect this guy, then I need to use a double arc because I've already used up a single arc. I hope that makes sense. So, yeah, good. So, arcs show congruency. These arcs right here that I've drawn show congruent angles. The arcs show congruent angles. Then triple them. Yeah. I don't think we go there very often, but we do sometimes. Okay. We're going to dive into constructions, and then if we have time, we'll come back and do some more angle-y stuff. Ooh, I need to talk about how to name an angle. Almost forgot. Real quick. There are 4 ways to name an angle. This is on your vocab sheet already. I just want to make sure I go over notation with you because notation is always very important. You can name the angle using its vertex. Using its vertex. What's special about y? It's the vertex. So you need to put an angle symbol and then you put y. Because if you just put y, you've named a point, not an angle. All right, you can also name it angle XYZ. You can also name it angle ZYX. And you can also name it angle 1 because there is a number in the interior of the angle. If a number's not there, you can't make up one. It has to already be there on the diagram. When I chose to name it with 3 letters, what letter always came second? Good, Pranika. You already noticed that. If you choose to name it with 3 letters, it doesn't matter what comes first, and it doesn't matter what comes last, but you must name it with the vertex as the second letter. Okay. Now, sometimes you don't have the choice to name it angle Y. Let me tell you when you would not have the choice to name it angle Y. Look at this picture. Name angle 2 in as many ways possible. So I go and I find angle 2. It's this angle right here. So I could name it angle symbol, BEA, angle symbol, AEB, but I actually could not name it angle E. The reason this time I can't name it angle E, is because that's too vague. It's not specific enough. How do I know whether you're talking about angle 2, 3, or 4? You don't know. So when there's more than one angle at a vertex that shares that same vertex, you can no longer name it with 1 letter. You must use 3 letters. You must be more specific. The number represents just another way to name it. Sometimes I don't want to name it with 3 letters. So I put numbers in there just to give you another choice. That way I can talk about them more easy. That way when I'm talking about them with you, I'm not saying 3 letters every time. Okay. Okay, now we're going to talk about measuring, copying, and bisecting angles. A protractor, get it? Tractor. Ha ha ha. So some people get these tools mixed up, so I want to make sure we know their names. So we've got protractor, compass. Protractor, compass. Okay. To measure an angle with a protractor, there are a couple of specific things that need to happen. Number 1, the little hash mark, or yours might have a circle. That hash mark or circle must always line up with the vertex. It must be exactly on the vertex of the angle. The vertex is where the 2 rays meet. The second thing that needs to happen is the bottom of your angle, or rather one of the rays of your angle, has to perfectly line up with 0. You see how one of the rays of my angle is on the 0 of my protractor. Once you have those 2 things lined up, then you can read the number off. You start at 0, and you go, 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 until you land, and this angle is perfectly a 45-degree angle. It's right in the middle of 40 and 50. Now, sometimes your angle is not going to be perfectly horizontal. The bottom won't be horizontal. So please don't do this. I literally have students who do this. And then they read that number off, and they're like, oh, yeah, it's 150 degrees, when even though this angle is nowhere near 150. Okay, so yes, you either need to move the paper or you need to move the protractor, one or the other. Or subtract. I'm not going to go there. That's an amazing thought, but that will confuse some students. So I do want you to always have your protractor lined up with one of the rays. One of the rays better be pointing to 0. One of the rays better be pointing to 0. So I've got my hash mark on my vertex. I've got one ray perfectly lined up with 0. Now I'm allowed to read the numbers. Start at 0 and go until you get to your ray. So this looks like on mine about 124 degrees. It's right before the 125, 123, 124. Okay? Okay, so now we're going to use our compass and our ruler, and we're going to construct some things. We learned constructions last week, and we're learning them today. You're going to use all of those constructions on an assessment next week. So you were probably like, why did we do constructions last week? They weren't really on the test. Don't worry, they're going to show up on your assessment. It's a really fun one too, I think. Okay. So let's do this. We're going to copy an angle. So hopefully you have this, or you can just watch. That would be fine too. Let me zoom in a little bit. So there are 3 steps to copying an angle. There's about 3 steps to copying an angle. The first thing that you do is make an arc, pretty much any size you want, as long as you don't go past the end. So the first thing I'm going to do is put my needle on the vertex. Very important that it's on the vertex. And I'm going to make an arc. So that's step 1. Now, my arc might look different from your arc. The amount that I opened the compass does not matter. It just matters that I make an arc. Now I go down to the ray I'm copying it onto, and I make the exact same arc. So far I have identical twin marks. These are twins. I just copied an arc from my angle to where I want my angle to go. Here's the important part. Here's the part where it actually is unique to the angle given to me. Now I need to put my needle, see how that arc intersected twice? 1, 2. It intersected twice. So now I need to put my needle on one intersection and my pencil on the other. Look, I'm not in good shape. So I need to open my compass a little bit more. I went a little too far because I have this big Sharpie, just so you can see it. Look, that's perfect. Needle touches one, pencil touches the other. So now I go straight down. I put my needle right here, and I'm going to have a little arc going the other way. Once I have this opposing arc right here, I know that's where I need to head. So I start at my vertex and I head through that intersection right there, and voila, I have copied angle A right down here, only using a compass and a straight edge. How do I know that I did it correctly? I can measure with my protractor. So when I measure, I get that this is about a 71-ish degree angle. And I come down here, oh my goodness, look at that. Can you see that? 71-ish degree angle. Okay, you go ahead and try to copy an angle. I'm going to go ahead and copy angle B just to show it one more time. Y'all are welcome to try it as well, unless you're already done. I'm going to remind you of what those steps were. So step 1, you open your compass to an arbitrary amount, that means any amount that will fit, and you make an arc. Don't just make an arc. You have to go to where you want your angle to land and make the identical arc. Twin arcs. Twin arcs. The most important step is step 2, when you find out how big is my angle. How much is my angle open? Oh, look, I'm opened way too much. So I need to adjust my compass until my opening is pretty close. And then I go down here. Where do I put my needle? Where do I put my needle? Right here. It's really the only intersection that exists. And I make an arc going the opposite way. Then I only have one step left, and that is to connect this intersection with this vertex. So connect the dots like we're in kindergarten, and we have made a copy of angle B. If you wanted to measure your angle B, your new angle, what is that? What, 36-ish? 36-ish. Okay, we're going to move on to bisecting an angle. You ready? No, Fong, your first arc does not matter how big it is. Okay, this is my favorite one. You ready to cut angles in half? Let's do it. Let's cut this angle in half. Let's find the exact angle bisector. Okay, this one is really fun, and it only has 3 steps. Are you watching? Okay, we don't need to copy it anywhere. We're going to cut this exact angle in half. Step 1 is the exact same step 1 as copying an angle. Step 1, you make an arbitrary arc. It does not matter how big, everyone's could be different, and that's okay. You make an arbitrary arc. Now, you hit your angle how many times? You hit it 2 times. So now, my needle was at the vertex. Now I'm going to put my needle at one of the intersections and make a new arc. Now I'm going to put my needle at the other intersection and make a new arc. Isn't that so cool? Now I connect that intersection to my vertex. Whoa, I just divided this angle into 1, 2 congruent angles. They match, they're twins. I could get patty paper and confirm it by tracing them. Let me say one thing before. I know you want to practice this one. What's cool about an angle bisector, and we'll talk more about it on Tuesday, is every point that lies on the angle bisector is equidistant to the rays of your angle. Every point is equidistant. This one is the same distance to here as it is to here. This one is the same distance to here as it is to here. It's pretty cool. Go ahead and bisect that angle. If you need to see it again, I'm going to do number 4. Step 1, make an arc. Step 2, put your needle at one intersection. Step 3, put your needle at the other intersection. Mine just barely crossed. So that tells me next time I do an obtuse angle like this, I should probably open my compass a little bit more. And if they didn't cross, I can start over, and I needed to open my compass more. I'm going to do 2 arcs this time, because we used 1 over here. So there's an angle that's been divided into 2 congruent angles. So padding paper is a great way to verify your construction, to check your answer. You could use a ruler. For time's sake, I'm not going to. So I traced one of my 2 angles, and if this was truly an angle bisector, then that means that I've divided my angle into 2 congruent angles. Ta-da! Yay! Perfect! Okay, now the back of this paper, just to let you know, is this assessment is not until next Thursday. The back of this paper will be your review, the things you need to know for the assessment next Thursday. Next Wednesday, if you want to ask me about the back of this, you can. We just didn't want to waste paper. We wanted to use both sides so that we could make sure you're ready for next Thursday. You don't need to look at that yet, though. Okay, I want to go over a few more angles things before y'all have to leave class. So let's do 2 examples, and then our lesson's over. Let's look at this problem. It'll show up on your homework, so I want to make sure you're prepared. An acute angle measures 4x plus 22 degrees. What are all the possible values of x? So let's talk about what we know about the word acute. An acute angle. We talked about the range that an acute angle can be. What can an acute angle be? It needs to be greater than blank and less than blank. Good. So an acute angle needs to be greater than 0 and less than 90. Well, this is our angle measure. So 4x plus 22 needs to be greater than 0 and less than 90. Now this one is a double equation, kind of. There's 2 inequalities, one on either side. So we're going to kind of do this like double solving thing. It's really cool. So how would you solve for x? Well, you would subtract 22 from both sides. But actually, you're going to do it both sides this way. You're going to go this way and this way. Fancy, fancy. Okay, so now we have negative 22 is less than 4x is less than, what? 68? And then we're seeing 4 times x. So we need to divide by 4. Whatever you do to one side, you must do to all 3 sides. Divide by 4. And, you know, if you get a decimal, you get a decimal, and that's okay. X can be negative, and x can be a decimal. So what are all the possible values of x? X needs to be greater than 5.5 and less than 17. Greater than negative 5.5 and less than 17. Let me give you an example. Negative 1. Would negative 1 work? Well, negative 1 is in that range. So let's see if it works. If I plug negative 1 in. 4 times negative 1 plus 22. That's an 18-degree angle. That's an acute angle. That works. So no, angles cannot be negative, but a variable can be negative. Are we okay? Guys, we did not divide by a negative. We divided by positive 4, so don't worry about flipping the signs. You would do all of them, but I don't think I've ever done that in this class. I've never made you divide by a negative with inequalities. Try another one. Let's make sure we can do this. If you have to leave, you can leave. Okay, so how do we set this one up? It's a little bit different. We've got the word obtuse instead of the word acute. So first let's write down where an obtuse angle needs to fall. It needs to be greater than 90 and less than 180. So I've got 90 is less than, then I put my angle in there. 3x minus 30, which is less than 180. I add 30 to all sides first. I would not recommend dividing first. Get rid of that first. So what do we have? 120 is less than 3x, which is less than 210. Hopefully I'm doing my math right. Divide by 3, divide by 3, divide by 3. 40 is less than x, which is less than 70.